Welcome to Spaceverse, your portal to cosmic adventures. In the event that a star the size of Jupiter were to rebel, what would happen? Betelgeuse, which is one of the brightest stars in the sky, is currently going through a peculiar transition that has given astronomers a sense of both confusion and excitement. Imagine a star that is so enormous that if it were to be placed at the center of our solar system, it would be so large that it would dwarf our Sun and all of the planets, with the exception of Jupiter. The red supergiant star known as Betelgeuse is located in the constellation Orion, and it is a truly terrifying object. Stargazers have been mesmerized for millennia by the beautiful ruby hue and enormous magnitude of the Betelgeuse constellation. Now, however, this cosmic giant is behaving in an odd manner, and astronomers are more concerned than they could well be. Betelgeuse's brightness suddenly surged by more than 50%, propelling it up the brightness scale from 10th to 7th brightest star in the sky. All of this occurred in an instant. It is incredible how things have turned out this way. The abrupt transformation of Betelgeuse has piqued the interest of the scientific community, while also leaving them bewildered. This is a really peculiar pattern of conduct. What might possibly be the cause of it? Is Betelgeuse on the verge of experiencing a transformation that will be disastrous, or is it really just a passing phase? In order for us to understand the significance of Betelgeuse's unique behavior, we need to conduct research into the factors that cause a star to shine. There are a number of factors that influence the brightness of a star, including its size, temperature, and the astronomical distance from our planet. Betelgeuse is an extremely massive star, as evidenced by the fact that its radius is bigger than 700 times that of our Sun. Betelgeuse has surface temperatures that range between 3,000 and 3,500 Kelvin, which is relatively low for a star despite its enormous size. These temperatures are responsible for the distinctive red tint that Betelgeuse appears to have. In ancient societies, the star Betelgeuse has long been a source of fascination, and these cultures have included it into their stories and mythology. Egyptians believed that Betelgeuse was connected to Osiris, the ruler of the underworld, while Greeks believed that Orion, the famous warrior, was tied to Betelgeuse. The aforementioned accounts provide evidence that this cosmic marvel have an enduring allure. When scientists are keeping a watch on the odd behavior of the star, they are forced to ponder the future of Betelgeuse, which is a riddle that they are obliged to consider. This is a situation in which the stakes are quite high, and the potential outcomes could be truly extraordinary. In the event that Betelgeuse is indeed on the verge of exploding, the night sky could be illuminated by a supernova explosion that is unlike anything we have ever witnessed before. Given the extreme luminosity of the explosion, it would be possible for scientists to observe it even during the daytime hours. This would enable them to investigate it through the phenomenon of shadows projections on Earth. Is this a momentary blip on the cosmic radar caused by a star giant, or is it the beginning of the stillness before the cosmic storm? One must have an understanding of the huge magnitude of the star, as well as the current stage of its life cycle. Betelgeuse and other red supergiants are examples of stars that are nearing the end of their lives and are on the verge of passing away. Birth, evolution, and death are the three stages of life that are characteristic of all living things, including stars. Nebulae, which are gigantic clouds of gas and dust, are in the process of giving birth to protostars. Nebulae are formed when the force of gravity draws the constituent pieces together. The birth of a new star occurs when these protostars amass sufficient mass and heat to initiate nuclear fusion within their cores. By using their nuclear fuel over the course of millions or billions of years, stars such as Betelgeuse are able to transform hydrogen into helium and helium into heavier elements. As these stars get older, their internal dynamics go through a series of changes that occur throughout their lifetimes. In the same way that Betelgeuse does, a red supergiant is a star that, when its fuel runs out, expands to an enormous size. Because gravity is only just about holding the star's outer layers together at this point, the star is exceedingly unstable. As a result of their own enormous gravity, red supergiants like Betelgeuse are destined to collapse and explode into a spectacular cosmic explosion known as a supernova. Supernovae are among the phenomena that are the brightest and most powerful in the universe. This is because they release an enormous amount of energy in such a short period of time. As a result of the fact that it has used all of its nuclear fuel, the enormous star Betelgeuse will eventually explode as a Type II supernova. When the core of the star collapses, it causes a shock wave to be released, which in turn causes the star to be torn apart and its outer layers to be propelled into space at breakneck speeds. If Betelgeuse were to experience a supernova explosion, it would be possible to witness a spectacle that has never been seen before. In the first place, the impending explosion would be indicated by a massive flood of neutrinos, which are mysterious subatomic particles that only rarely interact with matter. These neutrinos would have escaped the core of the star in the seconds before the shock wave occurred over the hours that preceded the illumination of the supernova. There would be a need for observatories located all over the world in order to detect this neutrino burst, which would alert scientists to the imminent supernova. When the shock wave strikes Betelgeuse's surface and the star explodes, an immense amount of energy will be released as light, heat, and radiation. The supernova would shine so brightly that it could be visible during the day and cast shadows at night, outshining the full moon. Astronomers are eager for this rare event. Dr. Emily Thompson of UC Berkeley calls Betelgeuse a ticking time bomb, offering a once-in-a-lifetime chance to study a massive star's death. Such a supernova would provide invaluable insights into stellar evolution, nuclear physics, and the universe's chemical makeup. However, Betelgeuse took an unexpected turn in late 2019, dimming to 40% of its usual brightness instead of growing brighter. This sudden change stunned astronomers, prompting urgent research to uncover the cause. One of the most exciting challenges that astronomers are currently facing is the darkening of Betelgeuse. Could the strange behavior of the star be an indication that a supernova is on the horizon, or could it be something altogether different? As we consider the various possibilities, the mystery deepens, and we eagerly anticipate the arrival of new observations and data. Despite this, the story of Betelgeuse is still beginning to develop. The fate of this enigmatic star will reveal the most important knowledge about the universe and the place that we occupy inside it. The odd behavior of Betelgeuse never fails to astound researchers. This is because the star is the source of a steady stream of fresh hypotheses and observations for astronomers. It is a race against the clock for scientists to figure out why the red supergiant star is behaving in a manner that is not consistent with its behavior. The cosmic drama is reaching its finale. In late 2019, scientists were taken aback by the sudden drop in the brightness of Betelgeuse, which is one of the brightest stars in the night sky. It was as if their once constant star was suddenly beginning to fade away right in front of their very eyes. Nobody could quite put their finger on what was happening, but everyone assumed that the star was going through a big surface explosion or that dust was obstructing our eyesight. Astronomers quickly focused their telescopes on Betelgeuse as it dimmed, hoping to uncover the cause. Childs' Very Large Telescope, VLT, one of the world's most advanced observatories, captured crucial images. These images revealed that Betelgeuse was no longer symmetrical. Once appearing as a flat disk, the star now looked bent and distorted by an unknown force. Further analysis uncovered a shocking anomaly, an intense shock wave directly in our line of sight, seemingly erupting from the star's surface, signaling something highly unusual was occurring. Exploring the concept of a photosphere is necessary if we are to have any hope of comprehending the significance of these discoveries. It is referred to as the photosphere, and it is the layer that a star uses to emit light into space. You might think of it as the visible surface of the star. Over the course of time, the photosphere of Betelgeuse is only subject to minute shifts, as astronomers have long believed to be the case. On the other hand, the photographs taken by the VLT indicated anything but that. According to their observations, the photosphere of Betelgeuse had started to expand, which resulted in the star having an appearance that was unprecedentedly enormous. In the manner of a cosmic balloon, it appeared as though the star was being steadily inflated by an invisible power. While scientists were in a hurry to comprehend these findings, they discovered two further abnormalities that might explain the behavior of the star. Around the middle of November 2019, a dark southern hemisphere was observed on the surface of Betelgeuse. This occurred as the star was getting closer and closer to the peak of its dimming function. The fact that this region, which was originally almost as bright as the star as a whole, is now substantially darker, is evidence that the star's appearance has undergone a significant transformation. Betelgeuse's surface temperature experienced a significant drop at the same time, as observed by astronomers. 3 months after the star's typical scorching temperature of approximately 3,500 degrees Celsius, 6,332 degrees Fahrenheit, the star had cooled several hundred degrees. This temperature shift, which is exceedingly unusual for a star of the type Betelgeuse, suggests that the surface of the star was subjected to a swift and significant occurrence. Before we can fully appreciate the peculiarity of this temperature decline, we need to investigate the properties of red supergiant stars such as Betelgeuse. Because they have exhausted all of the hydrogen fuel that they contain and have begun fusing heavier elements, these gigantic stars are getting closer and closer to the end of their world. These phenomena have resulted in their expansion to astronomical proportions, with radii that are many orders of magnitude greater than the Sun's. The temperature of red supergiants is actually lower than that of younger, smaller stars like our Sun, despite the fact that they are quite big. The reason behind this is that because their atmospheres have become larger, they are able to release more energy into space, which results in temperature reductions on their surfaces. On the other hand, these temperature shifts typically take place at a glacial pace, sometime over the course of decades at most. It is also exceedingly unusual for the temperature of Betelgeuse to have dropped so drastically and in such a short amount of time. Taking into account this observation, it is plausible that the star's typical mechanisms for regulating its temperature were disrupted as a result of a significant surface eruption. Betelgeuse had very likely been through a significant SME, according to the astronomers, who were coming to a worrisome conclusion as the data accumulated. When a star discharges a significant portion of its mass into space, it results in a tremendous eruption that is referred to as a surface mass ejection, SMEs. Despite the fact that SMEs have been the subject of theoretical discussion for a considerable amount of time, no one had ever seen one on a star. This insight opened the door to consequences that were just staggering. If it turned out that Betelgeuse had, in fact, been affected by a small-scale earthquake, this would suggest that the star was far more unstable than was previously thought. As a result of the event, speculation began to circulate regarding the star's lifetime and the possibility of its destruction. However, the surface mass ejection also provided astronomers with a wonderful opportunity to utilize their skills. Examining this unique occurrence in real time will allow for a better understanding of the systems that drive the growth of large stars. The cosmic drama of stellar death and rebirth was brought to life, and it was an opportunity to get a first-hand look at the enormous-scale cosmic recycling of stars. To what extent is it feasible that the dimming of Betelgeuse is only the beginning of a far more significant mystery? It is possible to compare the tremendous surface mass ejection, SME, that Betelgeuse experienced to a massive volcanic eruption that occurred on a scale that is comparable to that of the heavens. Imagine the following: a cosmic behemoth, a star that is so enormous that it dwarfs our Sun, suddenly and unexpectedly releases an enormous quantity of material from its surface. A portion of our vision of the star is obscured by the immense plume of gas and dust that was produced as a result of the shock waves that were unleashed by this stellar explosion. The size of Betelgeuse's small and medium-sized enterprise is quite astounding. As far as astronomers are concerned, the mass ejection from the star was 400 billion times more than what is often observed regarding stellar occurrences. To give you an indication of the magnitude of the situation, the amount of material that Betelgeuse emits on Earth is several times greater than that of the Moon. When compared to the mass that was ejected, Mount Everest would look like a pebble if it were collected and shaped into a mountain with the same characteristics. In order to put this into perspective, the quantity of material that Betelgeuse expelled into space is so massive that even if all of the water on Earth were to be converted into gas, it would be minuscule in comparison to the quantity that Betelgeuse released. A cosmic marvel of incomprehensible enormity, the SME was a manifestation of the tremendous size and power of the cosmos, which was on full show in the entity. Nevertheless, the SME was comprised of more than just a show. The impact that it had on Betelgeuse was also considered to be major. This caused the star to lose a significant amount of material, which resulted in a change in the duration of its pulses. Betelgeuse's surface would undergo a cycle of expansion and contraction every 400 days prior to the invention of the SME. However, that term was cut in half, and it was reduced to 200 days after the ejection. Alterations to the pulsation period of a star can have a substantial impact on the star's stability as well as its total lifespan. This could be an indication that the star is going through a transitional stage if there are disruptions to the pulsations of the star, which are similar to the heartbeat of the star. According to the altered pulsation period, it would suggest that Betelgeuse is coming closer to its final conclusion, which is a dazzling explosion of a supernova. In an effort to acquire a more comprehensive understanding of the factors that led to Betelgeuse's SME, astronomers turned to cutting-edge scientific models. By constructing exhaustive models of the stars inside with the assistance of powerful supercomputers and intricate algorithms, researchers were able to recreate the intricate physical processes that are responsible for the star's activity. According to their calculations, a gas current that was as hot as a massive burning bubble ascended from deep below Betelgeuse and burst through its surface, causing material to be expelled onto the surface. In the sort of simulations that astronomers utilize, modern science has produced miracles that have never been seen before. They encompass a wide range of features and qualities, ranging from the mass and temperature of the star to its magnetic field and rotation rate, making them quite diverse. By creating a digital duplicate of the star, sometimes known as a virtual clone, and feeding it data from cutting-edge telescopes such as the Very Large Telescope, VLT, and the Hubble Space Telescope, researchers are able to investigate Betelgeuse in a level of detail that has never been seen before. These models can be utilized by astronomers in order to study the possible causes of the SME and pulsation changes observed in Betelgeuse, as well as the potential repercussions of these differences. It is possible that they will be able to see the star's development, metamorphosis, and final extinction in a cosmic firestorm through the use of modeling that spans millions of years. In addition to providing a fascinating peek into the inner workings of the star, the simulations also illustrate the complex and frequently unexpected dynamics that shape our universe. What cutting-edge techniques and operational processes are astronomers employing in order to uncover the mysteries of Betelgeuse in the final moments before the star explodes into a supernova? At what point will the Betelgeuse star explode? In the future, astronomers will be faced with one of the most significant questions. The lifespan of the star is estimated to range anywhere from 10,000 to 100,000 years, depending on its characteristics. Due to the fact that the lifespan of a star is influenced by a number of different factors, it is difficult to predict when a supernova will take place. Three of the most essential criteria that are considered when attempting to forecast the longevity of a star are its birth mass, its chemical composition, and its nuclear fusion rate. Betelgeuse, a red supergiant, has exhausted its supply of hydrogen fuel and is currently operating with heavier elements as its primary source of energy. This approach is ineffective and has the potential to give rise to instability within the star, which can speed the star's subsequent catastrophic demise. Even in the event that the supernova occurred today, it would be some time before we would learn about the Betelgeuse stellar explosion. Due to the fact that the star is around 650 light-years away from Earth, it would take 650 years for any signal or light that emanated from the explosion to reach our terrestrial planet. The essence of the matter is that we do not see Betelgeuse in its current state, rather, we see it in the form that it was in 650 years ago. The concept of light years is essential in order to make sense of the huge distances that are measured in astronomical measurements. It is commonly referred to as a light year because the distance that light travels in 1 year on Earth is approximately 9.46 trillion kilometers, which is equivalent to 5.88 trillion miles. Taking into consideration the fact that even if one were to travel at the speed of light, it would still take 650 years to arrive at Betelgeuse, this is very significant. Astronomers are currently in possession of a once-in-a-lifetime opportunity to explore the surface of a star in a manner that is both close and intimate. The future of Betelgeuse is still unknown. Through the study of the supernova's fading and large surface mass ejection, scientists are able to obtain insight into the behaviors of aging stars, as well as the processes that occur before to a supernova. The consequences of this discovery were extremely significant for a number of subfields within the field of astronomy. When we are familiar with the surfaces of distant stars and exoplanets, we are better able to determine their chemical composition, atmosphere conditions, and whether or not they are habitable. Further, by researching star life cycles such as Betelgeuse's, we gain a better understanding of the evolution of the galaxy as well as the distribution of heavy elements. The first ever observation of a star devouring its own planet has been made by astronomers, and it is a fascinating discovery that causes us to wonder what will happen to Betelgeuse. This cosmic, cannibalistic star system was located 12,000 light-years away in the constellation Aquila, and we were able to locate it with the use of modern instruments and innovative ways of inquiry. By analyzing the minute changes in starlight that occurred as the planet was being consumed, astronomers were able to piece together what had occurred and become more knowledgeable than ever before about the dynamics of star-planet interactions. As a result of this groundbreaking discovery, we may now be able to gain a deeper understanding of the processes by which planetary systems build and evolve, and perhaps even of what ultimately transpired with our own solar system. When it comes to their study of Betelgeuse and other celestial marvels, astronomers consistently demonstrate their inventiveness and dogged perseverance. As a result of our unrelenting pursuit of technological improvement and strategic innovation, we are getting closer and closer to discovering the answers to the most critical questions concerning our place in the universe, as well as the unknowns of the cosmos itself. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and hit the notification bell so you never miss an update from Spaceverse. What do you think Webb will uncover next? Let us know in the comments below.